looking at worksheet number 4 of the standard S-CP.A.1, and we're still developing this idea of just basic probability, sample spaces, organizing our ideas. And we're introducing what is called, I didn't even write it up here, the Venn diagram. Now the Venn diagram is a very helpful way to organize relationships when it comes to probabilities. And so we'll cover a number of items here and maybe over a couple of videos to do it. The first thing I guess I would say with a Venn diagram is you create an overall boundary, and that boundary is usually just a rectangle. Not that there has any significance to that, but that's usually how it goes. The boundary represents everything that's possible inside of here. So it's your overall idea. So in this case, we're going to roll our D20. We're going to pick up this beautiful purple dice. Got 20 sides. Shake, shake, shake. Roll it. And so what we do is we name the universal set. Now the universal set is rolling a D20. Now I'm not going to list that out, but you know what's there: a 1, a 2, a 3, a 4, all the way up to 20. Now once you have your universal set defined and your boundary defined, you can start to create what are known as the subsets. Now getting a subset of evens, the set E where they are even, you just create any old boundary and you would start to list them out. 2, 4, 6, 8, 10, 12, 14, 16, 18. Let's see if I got them. 2, 4, 6, 8, 10, 12, 14, 16, 18. Whoa, what about 20? And a 20. There they all are. 0 is not in the group because it's 1 through 20, right? So, and then we would list maybe a little letter E there for all of the evens, okay? No magic to the boundary, just make it large enough that everybody can fit on there. Now let's teach you about a term called mutually exclusive. Now what that means is that you can have another set that has nothing in common with this group. Now can you think of another group of how to define some numbers that when you roll that have none of these numbers? There's lots of ways, but the other way is getting an odd. So this guy here would be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. It would have all of the odds, and this one's called G. So notice the boundaries don't touch each other at all. We have one boundary and another boundary, and they have no overlap to each other. That's what are called mutually exclusive. Now, what happens, okay, so let's, oh, I know. So we've done universal set. Let's do the complement, actually. So, well, let's do it this way. Let's start a new setup here. So let's look at F. It says the numbers that are smaller than 7. So that's easy. That's a 1, a 2, a 3, a 4, a 5, and a 6. This is this group. So that's set F, right? That's the group of all in that group. Now, if you want to talk about everything that is not in F, things that are not in set F, but are in the universal set, it would be everything outside of that. So out here would be FC. Now you say, what does the little C stand for? And it's a little tiny C, goes in the upper, in the superscript there, and it represents the word complement. And really it represents the word not. So not F, that would be out here. So if I was shading all of the region that's out here, this would represent everything that's not an F, which is what? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is what is out in this region here. So the complement is everything that is not what you're looking at. An important word, not. All right, a couple other key little relationships. Let's keep playing with our Venn diagram here. Let me make another one quickly. Universal set. Let's look at getting a factor of 10. So a factor of 10 has a 1, a 2, a 5, and a 10, right? Those are the factors of 10. 1, 2, 5, and 10. Now that is H. Now, if I wanted to also draw, so this is set H, if I also wanted to draw F, the numbers that are less than 7, I notice that some of them are already listed here. And so I would need a 3, a 4, 1, 2, 3, 4, 5, 6. So now I want you to notice something very important just happened. The two sets, set F, which are the numbers smaller than 7, and the numbers that are factors of 10 share some numbers. That is called the intersection. This is the intersection of those two. Now there is some notation for that, and I know you're not going to like this, but this little kind of upside down U, I think it looks like an N for intersection. Intersection. Think of it as like the N from intersection. So the intersection of these two would be a 1, a 2, and a 5. So if I want to talk about what's in common, so you use a couple of things. We use the words and here. We use what's in common, and it's called the intersection. So if we are talking about the intersection is what's in common, what is in this and in this. It's the overlapping region. And the official symbol is this kind of N looking upside down U, and this is what's in that location. Now in mutually exclusive sets where they are separate and have nothing in common, they have no intersection. And if that's the case, they have an empty set. Now the symbol for empty set is the null symbol, which is the 0th with the line through it. So if you have two mutually exclusive sets, nothing that touches or is in common, no and, then they have an empty set. In this case, they have some overlapping and they have an intersection. Now while I'm here, and I'm almost done, I want to talk about the phrase or. So in probability we say this or that. Or is another way of speaking about the union of things. The union of the states was to put them together. So we're going to union these, and we use the phrase this or that. So if we wanted the probability of getting a number 1 through 10, a factor of 10, or a number smaller than 6, the or basically includes everybody in there. So, and we write that as set H union, the U for union, that makes sense, set F, and our values would be a 1, a 2, a 3, a 4, a 5, a 6, and a 10. The union is all of that put together is our union. So we have an intersection, which means the overlap, the in common. You have the or statement, which means union, which is combining everything together. And I think that's a pretty good place to cut this. The only thing maybe I'll say is there is some notation. I'll go quick here. Sometimes you might list things that look like this. This is when they have some value in common. They might look like this. This is when there are no things in common. And you might also get this where everything is in common. So for instance, let's modify this. Let's say this is getting a number less than 3. Now, getting a number less than 3 is a 1 and a 2, but getting a number less than 7 is also 1, 2, 3, 4, 5, and a 6. This guy, let's see, H is a subset H is a subset of set F. This little sideways U means subset of, and it sometimes has an equals here, so it can be equal or smaller when it's a subset, okay? This means equal or smaller. This means it is just strictly smaller. So this case, you can also write it like this. This is also true. It is smaller or equal, and it's smaller, so we're okay.